This is the problem on the temperatures on the moon, and it reads as follows. On the moon, the surface temperature ranges from 375 kelvins during the day to 1.00 times 10 to the second kelvins, or exactly 100 kelvins. What are these temperatures on the Celsius and Fahrenheit scales? We have given two temperatures and we're supposed to convert them to Celsius and to Fahrenheit, which means we're going to come up with four answers. So we have, I can leave it at that one. So TK is given. The first TK is given as 375 kelvins, and the second TK is given as 100 kelvins. Okay. And I don't think I need this box here. It's pretty much just converting from one temperature to another. So in order to come up with the Celsius temperatures, I need to subtract 273, and then I come up with the Celsius temperature, so TC. I know it says 273.15, but it looks like we're truncating after the integers. So obviously I can write down the result here, 102 degrees Celsius, and on the other one I would do the same thing, minus 273. So in Celsius that's going to be minus 173 degrees Celsius. That was supposed to be a C. I think I might need a little bit more space. Okay. Then the Fahrenheit temperature. And here what I need is the conversion. Temperature in Fahrenheit equals the Celsius temperature times 1.8, and you're probably finding in places that it says 9/5. I just like to write down the 1.8 instead of the fraction, and then add 32. And that's how we convert between the Celsius and Fahrenheit temperatures. So I take 102 and multiply that by 1.8, and then I add 32 to that, and I come up with something, and I'll leave that up to you to do that in degrees Fahrenheit. It's going to be a large positive number, and then I do this down here for the Fahrenheit temperature. And as I multiply this by 1.8 and then add 32, I come up with a large negative Fahrenheit temperature. I picked up this thermometer here from the software, and I can move around here on the Celsius scale, but notice that the temperatures on the moon are off the scale. This is a normal weather scale, or for the weather here on Earth, and then I can switch from Fahrenheit to Celsius, and that's what I figure I'm going to do here in addition to this problem I just did. So I'm going to scroll down here and make up another couple of problems, perhaps change the color. There we go. So this is besides the problem that I just did. Let's say we have a Celsius temperature. Ooh, geez, maybe I didn't want to do that. That was a little bit too much. Okay, I'll try another color here. Okay, let's say I have a temperature of 74 Fahrenheit. So, nice summer temperature, I guess. That for always smears. Okay, now using this equation up here, I'm going to go the opposite direction. So I subtract 32, which is 42, and they divide by 1.8, and I have to do it on the calculator, and I come up with a rounded 23 degrees Celsius. Let me take a relatively high temperature. So let's say 100 degrees Fahrenheit. And I subtract 32, which is 68, and then divide by 1.8, and that is a rounded 38 degrees Celsius. And then I take, let's say, a relatively low temperature. Well, actually, relatively for us in Alaska, that's not necessarily common if you live in the south of Alaska, but we can hit that temperature definitely. So negative 20, I subtract 32, which is negative 52, and divide by 1.8, and I come up with negative 29 degrees Celsius. Okay, this I actually have to do on the calculator. Of course, I can look at this thermometer here as well. So I go to, my first one here was 100. There we go. And then, okay, 99. I switch over here, 37. As I said, it's a little bit hard to get that exactly onto that temperature. There it's 100. Okay, and there it's converted. 38. And then I had 23 degrees Celsius, which is there, maybe. It's a little bit trickier. So 23 degrees Celsius, I guess 73 or 74 if I go up to 74. It depends on how it rounds or how it converts. I can't get to 74. Okay, so negative 20. And again, it doesn't want to stay there exactly. There we go. Negative 20. And that's negative 29 degrees Celsius. So obviously if I have a thermometer that measures both Celsius and Fahrenheit, then I can just read off one or the other, or make this long conversion. Now, here's a little thing that could come in handy. These numbers on a temperature scale, they're actually easily converted. I'm sorry, these numbers on the temperature scale as far as the weather is concerned are easily converted. If you don't need that much accuracy, for example, you're talking to a tourist and they have no idea what 100 degrees Fahrenheit is, and you say, well, here's an easy conversion. Instead of using this here with the 1.8 and 32, you use instead 30 and a multiplier of 2. So here it is. 100 degrees Fahrenheit minus 30 is 70, divided by 2 is 35 degrees Celsius. 74 minus 30 is 44, divided by 2 is 22 degrees Celsius. Negative 20 minus 30 is negative 50, divided by 2 is negative 25 degrees Celsius. Notice how quick this was. I need a calculator. I can just do it in my head. Because of dividing by 2, it's advantageous to actually have even numbers, so you don't have to think too much. But this kind of approximation can easily be used out on the street with a tourist, and then you don't have to think much about it. But of course, it's just a side point here for me, or footnote, because the problems that we encounter here, we have to do, I guess, the exact conversion. This is just a very good estimate, as you can see.